So, as Kara said, my name is Trey Torrance. I'm currently a systems engineer for NCC Group's domain service. And just to give you a little background there, we're running a TLD that is more or less security oriented. It is the .trust top-level domain. It just launched this week, and so we've been doing a lot of this work that I'll be talking about today.
Can you move the mic closer to your mouth? Just
Sure.
Your chin. Sorry, it's hard to hear you.
So we've been working on this for about 2 years towards this security product, and a lot of the reasons that we chose this are tied to the security aspects of our company. So to give you some background, as I said, I'm a systems engineer, have been a systems administrator in the past, more or less the same role. I've been working with Puppet for about 5 years, and Code for about 4. And in my spare time, I hack on things. So what we were working with prior to this, we had already built up a very sophisticated Debian packaging solution. We had excellent repository support for deploying our packages. And all of this was greatly simplified by a tool called FPM. So when we started to get ready to deploy services, we started relying on what we already had. And that was largely Jenkins, which built our packages, and Puppet, which managed the services, the packages, and everything on the actual servers. So the first thing we did, as I'm sure a lot of folks in this room have done before, is we had Jenkins start running Puppet for us. That was kind of awful. It was slow. There were a lot of ambiguous errors that would stem from operations, but would cause a developer's code to not deploy. And so no one was really clear on who owned that process, and as a result, no one really did. And again, it was very slow. Deploys took maybe 20 to 30 minutes, sometimes longer. So we realized that this was not going to scale. We started with a single Rails application, but we were quickly building a service-oriented architecture, and we wound up, the world we live in today, we have about 8 or 9 Rails applications. So we started re-evaluating our deployment strategy. We started looking around at the tools that were already out there, and some of them, maybe some of you are familiar with, some of them I know I was. I have worked with Capistrano a lot over the years. For a long time, I was a moderator of that IRC channel. I've used it to deploy Rails code. I've used it to deploy my Puppet modules before R10K. So I was very familiar with Capistrano, loosely familiar with Ansible, Fabric, and of course, some folks just use custom shenanigans to get their code out there. That's pretty common, and there's nothing wrong with that if that's working for you. But all of these solutions had some really, really difficult shortcomings for us. So let's talk about that a bit. Capistrano, Ansible, Fabric, basically all these tools are SSH based. And what that means is you have to manage the keys out of band, you have to manage server enumeration in your deploy scripts. It gets complicated. And so for us, that was a problem. For scale, we use EC2 right now, which meant that host enumeration was kind of painful. Servers in EC2 die a lot. Sometimes they're there, sometimes they're not. And we usually get a friendly message from Amazon about a day after it dies saying, hey, we scheduled maintenance on the hardware that that node was running on. You might want to move it. So we didn't want our deploys to fail simply because Amazon had a hardware issue. We didn't want to have to go edit those scripts, change IPs, change host names to accommodate for that. The other problem with scaling was the transport. SSH is great for administration on a single node or even a couple, but it doesn't scale super well to N. And then the main challenges that we really couldn't get around were the security aspects. Most of these tools have really rigid models. Most of them don't really even think about their security model. So it's more or less just, hey, set up a user, set up an SSH key, and go. And it leads to a lot of sort of poor Unix administration practices when it comes to things like Capistrano deploy scripts. You can do it right. I've done it right before. It requires a lot of manual effort, a lot of user group alignment, and it's not the most understandable thing for someone that's not a Unix administrator by profession, which is often the case with the folks that actually run the cap scripts. So, and as I said, SSH access has a lot of trade-offs. There's security on the wire, that's great, but key distribution is a hard problem. we've all run into that in other contexts. And so we, again, didn't want to have to wait full Puppet cycles to export an SSH host key and then re-import it on target nodes. We really wanted to be able to deploy to whatever servers were out there the moment we said go. So we knew that MCollective looked promising, and I'm going to stop for a minute and give a little background on that, in case folks aren't super familiar with what it does. Ryan talked about it earlier today. It's basically a pluggable orchestration framework. So clients use applications to trigger actions on agents across your servers, and they use data to do this. I've capitalized those words because these are core concepts in it, and they're all pluggable. So by default, your data comes from Factor, which is really handy for anybody in a Puppet environment. But it can come from Ojai or a number of other sources. Agents more or less do whatever you need them to do. Puppet provides a number of common ones out of the box that rely on Puppet itself, which is really powerful. So we were able to quickly throw together an MCollective stack that relied on the Puppet Labs plugins to do things like package management, service bouncing, Puppet runs, and more importantly, locking Puppet runs to prevent Puppet from running in an inopportune time during a deploy. And we were able to see sort of how this might work for us with our packages and the way that we had structured things to be very Puppet friendly. So that's what MCollective does. Now, why you would want to use it, like Ryan said, it's great for ad hoc execution. Puppet is great for out-of-band management. It's great for saying, hey, I would eventually like my environment to look like this. MCollective fills that gap of, right now, I absolutely need everything to do this. So even outside of the deploy space, one of the things we use it for very heavily are patching. OpenSSL updates, we've had probably 6 in the past 6 months, and we've been able to roll them all out to all of our servers in about a day. And that's pretty powerful for us. Honestly, the rollout takes a few seconds. It's bouncing all the services that use it that take the time. So the other why is that it's infinitely extensible. If you can write a little Ruby, then you can basically make MCollective do whatever you need it to do. And that is super powerful. And how it works, like I said, there's Ruby that actually powers the MCollective daemon, that powers the agents and the applications. There's a message queue layer that's actually how MCollective communicates with your infrastructure. And there is SSL. That was key for us. That solved a lot of problems. We were able to figure out a strategy to reuse Puppet certificates and to just basically get all of the encryption and authorization we needed for free without having to re-implement anything. That was huge. So this looked like a real clear winner for us. So we moved on and started the POC. And we started to think about what we really wanted out of this. And we said, wouldn't it be great if we didn't have to re-architect the way we build our software? If we didn't have to add apps, if we didn't have to change our deploy code to add apps. Because again, as I said, we have now 9 apps. Sometimes we kill one off, sometimes we add another one. That number changes a lot. Wouldn't it be great if the deploys trigger downtime and Nagios so that we didn't have to just kind of accept that we're going to get paged when code's being rolled out? Wouldn't it be great if for rollouts we're aware of how we had architected our redundancy? We use availability zones in Amazon. And these are more or less promises of isolated infrastructure in the same data center. And so we rely heavily on building out redundancy across these AZs. And as a result, we would like to deploy in some contained fashion to these AZs so that if we bring one down, the others are up. And it would also be great if the app's health checks that we have the developers build in could gate the rollout. We deploy code, we check to see if it's healthy, and if it's not, we stop right there. And in general, wouldn't it be great if some action could happen on some service in some other tier based on the fact that we're deploying? Yes, it would. So we sat down and we started writing. And honestly, it was maybe 200 lines of Ruby. And here we are today. We didn't have to re-architect our packaging. We don't have to change code to deploy new apps. We don't actually get paged when we're rolling out code. Our rollouts do work the way we want. And the health checks do gate the rollout. And of course, there are other things we may want in the future, but this is really great. We were right about that. And one of the things that we gained along the way is, the way that we can actually deploy without changing code and retargeting is we have these implicit things that MCollective gives us through its facts and its other data sources. But we can say, mco deploy foo to environment dev. And implicitly, MCollective says, hey, look at the environment, all the dev nodes that happen to have the package foo on them. Take this and run with it. And so for us, our servers just do what we need based on what's on them. It's sort of the other component to Puppet. With Puppet, you tell things how you want them to be, and with MCO, you can sort of ask things to happen based on the way things are. And this has been super, super useful for us. I mentioned before that our deploy times were up to about 45 minutes before this. Well, that's not the case today. As a matter of fact, we're still solving some problems, but deploy times are largely down about 75%. The things we're looking at now are, can we make HA proxy schedule downtime on the back end rather than rip it out from underneath it? This was an idea that my manager had about a week ago. And so now we're about halfway through implementing that. Can we get graphite deploy markers? And can we please find a better MCollective dev workflow? That's the big one for us. That's the toughest problem to solve. MCollective is really powerful, and as a result, you can break your system in really powerful ways at huge scale. It's impressive. So one of the things that we struggle with is that when we write new MCollective extensions, we have to be very careful. The agents are relatively safe to deploy and whatnot, but they're very tough to test. The code you write for them is straightforward. Testing it in a real environment is the only way I've figured out to do anything with that. And that kind of sucks. Likewise for applications. Testing those is much simpler. Writing them is much more difficult and more convoluted. I would love to see that change in the future. And I have some ideas, but they're not perfect, they're not fleshed out. If people have other ideas, I would love to hear them. I'd love to start a conversation on this. And of course, the question marks here are because as our environment grows, our deploy pipeline does. We have new ideas all the time, like the HA proxy idea. So the Nagios downtime was added about a month ago, and that was maybe 30 lines of Ruby. The HA proxy will be about 70 lines of Ruby. But these are simple things that we can make carefully, but pretty rapidly. And that's been huge for us. All of a sudden, we don't have a deployment tool. We have a deployment framework. And there's an important difference there. And that is that, a deployment tool does what it does. A deployment framework, you can meld it. You can make it do what you need. So as I mentioned, our deploy times are down. Our architectural redundancy is on it. If the first if the first server that we deploy in App 2 fails, then we stop rolling that service out. We have auditing. It's powered by Logstash, and that tells us who did what, where they did it, and when they did it. And we get that in a very granular format. And we know that the user is who it says it was based on PKI. So the other benefit here is that Jenkins can still do deploys for us, and we have greatly reduced the privilege that Jenkins needs to be able to do that. In the past, Jenkins could trigger Puppet runs as root on any server running Rails code. Now, Jenkins can only run the actual actions exposed by agents that we specify. And so we can say, no, Jenkins should be able to update the app repositories across nodes, but it shouldn't be able to restart Apache. It shouldn't be able to do X. And so for us, that security aspect, this aspect of least privilege that's so important for our business is preserved. And we can have Jenkins roll code out in dev, and admin rolls it out in production. And it's the same process in either way. It's a single line command. mco deploy foo -e some environment. And that's very, very, very useful for us. It's saved us just tremendous amounts of time. So I just want to stop for a moment and give some thanks. None of this would have been really easy to do or even possible without most people on this screen. So I'm calling out to Jordan, his team, and Elasticsearch in general, because for us, auditing is super important. And tools like FPM let us package things in an auditable way. Tools like Logstash let us track what happened in our environment. And tools like Elasticsearch allow us to get some really powerful information about that out at an analytics level. Thanks to Rip, he initially developed MCollective and Hyra. And thanks to Puppet Labs, because they support this whole stack. And that has just made my job a lot more enjoyable and a lot simpler. And so now I'd just like to ask if anybody has any questions. I would love to have been able to demo code, but unfortunately there's some IP restrictions there right now. So think of this more as a case study, but it's not very difficult to throw together at all. We did this with very little prior MCollective development expertise and just a little Ruby knowledge and the docs that Puppet Labs provides. It took maybe a week to deploy out there and get going in development. So
did you write one MCollective deploy agent where you had all your actions in, or are you calling individual agents like a package or?
That's a great question. So right now we're calling individual agents. I am considering moving to the other model. I'm of two minds. We could more easily open source this tool if we managed to just rely on existing agents. But I have found that it's really difficult to invoke multiple agents programmatically from an MCO application. So you start seeing things like your filters cross-pollinate across agents, and you have to kind of work around that in creative ways. So for example, I mentioned that we handle downtime in Nagios. So I wrote a custom agent that actually writes to the command file on Nagios and says, hey, schedule downtime on this server. And that is the only agent that doesn't run on the server that's getting code right now. And I couldn't make it work at first because the filters for the other agents were being applied there. And so it was never targeting my Nagios server, it was targeting my Rails servers. So I had to sort of figure out how to reset some filters and structure the code very carefully to get around that. And that's leading me to think that I should maybe rewrite this as an agent that does deploys and maybe rely on the external script feature that MCO provides so that you could sort of bring your own deploy script that knows how to update service foo on a single node, and MCO can just do the hard work of targeting and orchestrating it.
You mentioned that the Jenkins with the MCollective, did you write your own plugin or how did you do it?
We've written a couple of small plugins. Mostly we're relying on ones Puppet Labs provided. The main thing that we wrote was the business logic to actually handle ordering of rollouts. So just largely encapsulating our redundancy architecture was the main bulk of the custom code we wrote. Right?
Would you talk a little bit about the linkage between the deployments you do with MCollective and the public configuration you do on hosts?
Sure. So the main thing that happens is we already have Puppet build servers. So Puppet tells a server that it should have a package for a given application installed. For us, what MCollective does to link that up is two things. The environment filter that we put on there applies to a custom fact that we have. That's called NCC Inv. So that simply just checks to make sure that we're only targeting dev nodes if we wanted dev, only targeting stage if we wanted stage. The other aspect is that we do a Puppet data filter for the package we're deploying. And so we rely on a relatively pathological nomenclature. We always name a package after the app and the service after the package. And we simply rely on the built-in providers and the built-in filtering capabilities to basically query where Puppet is managing that thing.
So when you run an update, do you use a collect read the Puppet run, or you just run sequentially all the commands, all the engines, like update package, trigger service restart, load new configuration file?
So right now we do the latter. We update the package, restart the service, perform a health check within RPE. We thought about the other, but we get back into the Puppet runtime affects deploy time problem. And we're an agile shop, so 40-minute deploys are just really not something our developers want, nor do we. So that just hasn't worked well for us in the past because we have to stay very on top of scaling our Puppet manifests as much as the masters. Because if the catalog gets messy, then it's just going to take longer to compile. If there's an error, then you might not get your deploy.
You guys use MCollective for your pre-partial tests, like before you take the project into production, you actually test using MCollective for partials, and how do you manage?
So MCollective deploys in all environments. I'm not sure if that's what you were asking exactly, but in dev, in stage, MCollective controls the rollout. But we don't do any pre-deploy smoke tests on the servers that are getting new code. We trust our staging process and our QA process to validate new code, and then we push that out with MCollective.
Well, case in point, the OpenSSL patches that you talked about, do you just roll that out into production?
Yeah, so with OpenSSL patches in particular, and using it for things other than our custom application deploys, we will do, for OpenSSL in particular, for us that's a big pain point. Because in the cloud, as a security company, every service we deploy, we mandate that it has SSL support. And so for us, rolling out an SSL package is almost equivalent to rolling out a kernel update. It's that disruptive in terms of what we have to reboot. So what we do for that in particular is we have a bash wrapper around MCollective where we say, okay, go update the package everywhere, and now let's go through and iterate and bounce services safely per availability zone. So we'll loop through and say for service, for the HA proxy nodes, bounce all the ones in this availability zone. Wait for an admin to confirm that it went well. Bounce them in the next one. So we use it, in that case, more to enforce workflow and to take the mentally draining aspects out of that task so that it largely just comes down to watching monitoring and watching the prompt on the MCO wrapper and saying, are things healthy? Okay, I can go to the next step.
What do you think MCollective fit in if you start using immutable servers? So then you don't have to deploy an application after the fact from this build.
So possibly like a containerized environment or something like that? Is that what you're?
Yeah.
So there, it really, how MCollective fits into any environment is sort of it's an open question, right? It's so customizable and it's so, it's very much a framework out of the box. So you can really, with a little bit of Ruby skill, you can make it fit into most workflows. Whether or not it makes sense to is a whole different question. But one thing I saw recently, Rip, the original MCO author, did a blog post about how he uses Puppet, Docker, and MCollective together. And I thought there were some really interesting points in there. Things like using MCollective to actually manage the container layer on the hosts and things like that. I've got two, so I'll come back to you in a second. Sir?
You highlight one or 4 or 5 points. Our environment is a Jenkins deployment environment, so if you wanted to use collective, you already mentioned 1 or 2 points, just wanted to highlight.
Sure, so using Jenkins to deploy with something like MCollective. So what we do is we have a couple of mechanisms in place to reuse Puppet certificates. So every server, every MCollective daemon gets a copy of the actual node's agent cert. Every MCollective client, which is a user like yourself, myself, or Jenkins, we generate a certificate out of hand with Puppet cert generate. So we put that on, and that's how that user authenticates to MCollective. Now, every aspect of MCollective is pluggable and configurable. So you can then go in and add an authorization plugin that says, when the user comes from the Jenkins certificate, then that user can only run these actions on these agents and things like that. So that's one of the ways that you can restrict that and lock that down and prevent Jenkins from being able to do things to your infrastructure tier when that really isn't where it belongs. Any other things I can touch on for you there? And I think you had a question?
anything, especially since you're Amazon and it works the way it does.
So what we do, we have a general knowledge of what servers should exist, and the wrapper script or the application that we wrote does extensive logging of what servers it targeted and how well they did in each phase. And so that's up to the operator at the time of deploying. In the dev environment where Jenkins deploys, we just allow that to be a little more chaotic. In DR and production where admins are deploying, what we wind up doing is you look at monitoring before you start to deploy. You already have an idea if one of your nodes is down, and if it goes down mid-deploy, then you can catch that as the app rolls out and go, hey, it only went to 2 servers instead of 3 or 6 or whatever.
So if you're using the now, like if you have different type of applications, we usually use gap-wise like app-specific instructions, right? That's what I'm trying to look at. How does that work in MCollective?
So there are a few different ways you can solve that, right? We were already solving that with package post-install scripts. So for us, that's still largely where that happens, though I would like to move us away from that for a few reasons. Some things that you can do for that, if you're a Rails shop, it would be very simple to write basically a rake wrapper as an MCode agent so that you can trigger your DB migration task, and you can trigger these things with MCode calls like anything else. Likewise, there's also Puppet Labs started providing a shell plugin. Don't consider this an endorsement. It could be a very dangerous thing to roll out, as you could run arbitrary shell commands at scale. But that is one thing you could possibly use to solve that problem. There's just a lot of risk associated with that. All right. Thanks, folks.